Hello everyone. In this video, we are going to be doing an overview of AWS Secrets Manager. I'm going to explain why Secret Manager is useful, how it works, the pricing model, and finally, we're going to run through a demo of Secrets Manager in the AWS console. So I wanted to start this out just by talking about a very basic example of a user building an application that is trying to interact with Twitter. So say we have some source code here and the user is trying to build an app that interacts with that Twitter API, maybe to consume some live streaming data. And when you try to sign up with one of these vendors, you typically need to provide a username, provide a password, and then of course you get some kind of API access token back like I have here. And it usually looks a little bit something like this. And every time you want to make a call to the Twitter API using their client, you need to provide that access token in addition to whatever call you are making, whatever arguments you need to provide. So for those of you that don't know, this is what is called a secret, right? A secret is something that we want to hide from other users. We don't want anyone else to be able to see this value because effectively it gives whoever sees it the keys to the kingdom to call Twitter on our behalf and pretend they are us. This may be a problem if you put in your credit card, there's some kind of billing information that's associated with the key. There's a whole bunch of reasons why you want to protect this value or this secret. So this is kind of what we're working with here. So say you are kind of a good developer and you decide I want to use source control to store this information. So you use GitHub, of course. So you store your source code just like this into GitHub. And say this is a private repository for now, so it's not really being exposed to the public internet. But say, I don't know, someone comes along here to your GitHub account, you have some guy that's impersonating you, doing a phishing attack or something like that, and they happen to gain access to your GitHub account. Well, now they have access to your source control. And now they have access to this file here and this API token. And now they can call Twitter on your behalf. So this is the kind of scenario that you're trying to protect against with Secrets Manager. And the whole idea with Secrets Manager is that instead of storing these API keys or these access tokens, could be just a string, could be a database username and password, could be anything, could be your mom's recipe if you want. But anything that you want to hide from the user, you would put into Secrets Manager. So that's the core idea. Now, how is this solved in the past? Well, for a long time, people were just doing this, and this is bad for a whole bunch of reasons. Sometimes people like to use environment variables, so they'll create a environment variable in a special file on their computer and then reference it in their code here and say, instead of this being a string now, it would be get environment variable from some specific path. That does work, but it doesn't protect you in case someone gains access to the user's machine. And that user still gets to peek at this value whenever they want, right? Because it's just sitting on their machine, probably in plain text. So this is the problem domain that Secrets Manager solves for. So how does Secrets Manager make this any better? So let's take a look now at this other example. And this is going to talk about how Secrets Manager helps or solves this very particular problem that we just laid out. So we have this old code here. I just want to keep it here as reference for you to see the before, and then through the visual here, you're going to see the after. So it starts with you as the user. You need to interact with Secrets Manager. So you'll take that Twitter API key that we have right here, and you as the user will create and store a secret within Secrets Manager. And it's a very simple process to do it. You just create a resource with whatever name you want. It has an Amazon resource name like every other resource in AWS. And within that secret, that named secret, you provide, it could be either just plain text or it could be a JSON object with multiple records. So in this case, I just create a JSON object to store in here, and the key is Twitter API key, and the value is our Twitter API key value, same thing that we have over here. Okay, cool. So now we have, we're not storing this in source code anymore. We're storing this in Secrets Manager. So what do we need to do in the center here? How are we going to access this? Well, the idea is that now we change our source code slightly. So what we now need to do is we need to use the Secrets Manager client to call the Secrets Manager get secret value API, and we need to provide it our secret name, whatever our name is here that we created for this secret in that initial step. And then from there, we can assign a variable to the access token that extracts out of the response, so out of the response of this step, the secret string, And then this is just a dictionary object now, so we can just grab the value that has the key, Twitter API key. And now API access token has the value that is effectively this thing over here. And then you just move on your way, you call the Twitter API with the access token as you normally would. So in other words, instead of storing this data locally in source control, you now need to swap that out with making a API call to Secrets Manager. So the value of the secret, in this case the token, is only visible at runtime. It's not being stored anywhere. It's just being grabbed from Secret Manager and then thrown into kind of your application code here. Now, some of you may be saying to yourselves, like, this only solves half the problem, right? Because Secrets Manager is now storing this value within it. And by the way, it's not storing it just in plain text. Secrets Manager interacts with a service called AWS KMS, or Keymaster service, to encrypt your data. So you don't have to worry about that. But some of you may be saying, okay, like, what if someone just gets access to Key Manager service now, right? Like, won't they have access to my API key? And what if someone else tries to call a Secrets Manager and tries to grab my secret by name? Is that going to work? And the answer is no. And the reason is because Secrets Manager is very tightly coupled with AWS IAM, or Identity and Access Management. And this is the AWS service that's used to manage permissions. So permissions for applications, for users, for individuals with particular roles to have access to certain AWS resources. And your Secrets Manager secret is no different. It is also an AWS resource. So we get to leverage IAM, or Identity and Access Management, to guard access to our particular secret. So how this would work is that whatever application that is going to be running this code and calling the Get Secret Value API needs to either be a user or have a role that has certain permissions to interact with Secrets Manager over here. And so what needs to happen is that you as the user need to establish permissions for whatever application is going to be interacting with Secrets Manager. And then from there, you need to grant the Secrets Manager Get Secret Value permission policy to the user or role so that whatever is running this code will have access to Secrets Manager. So this is the central idea of how Secrets Manager works. You get to store all of your data privately in Secrets Manager itself. It's encrypted by KMS here, which sits kind of beside Secrets Manager. And then you guard access to your secrets using Identity and Access Management. And you can use some very, very fine-grained controls in IAM to say only particular users in a particular group or part of this, super user administrative group have access to this particular secret. So you can be super, super granular with this stuff using the full power of IAM. So this is the general idea of Secrets Manager. I want to just talk about some of the other features that are available with it really quick. So let's talk about kind of in general what Secrets Manager is now. So it's a managed AWS service that protects API keys, tokens, database credentials, anything that you want to hide from your end user and you only want visible at runtime, you can hide in Secrets Manager. And it's fully managed, which means that it's going to support very, very high scale for even super high throughput production workloads. Even if you need to do like thousands of requests to the Get Secret API, you have a whole fleet of machines that need to have access to it. Secondly, it's great because it centralizes secret storage and encrypts all of your data. And I already know what people are going to be saying. There's going to be some people in the audience that are going to say, oh, this is a really bad security practice. Centralizing all your security details or all your security tokens in one spot is a really, really bad idea because now if one person gains access to your AWS account, you lose access to all your secrets and you're totally screwed. Now, I kind of agree with you and I kind of don't. The reason I don't agree with you is because if you are any reasonable user, you should have an AWS account that's using MFA, multi-factor authentication. And one of the kind of assumptions of using Secrets Manager is whoever or whatever, if it's an application, is getting access to that secret, you lock down the permissions and you deny every other user access to that secret. So you need to be very, very careful when you are crafting policies that allow users to interact with your Secrets Manager secrets, or else you're going to risk just letting anyone that's on your AWS account reading them, and maybe they're very sensitive. It could be CIA secret keys or something like that. I don't know. But that's kind of my counter argument to that. In addition, like we learned, access is managed through IAM, or Identity and Access Management. If you're not familiar with it, I'll leave a video to one of my core concepts videos on IAM where you can learn all about it. And the cool thing about this too is that you could monitor access to specific secrets through CloudWatch and even through CloudTrail. So you can combine those two things together. So for example, if you use CloudTrail, you can monitor all the requests to get secret value for a particular secret and then collect all of the IP addresses that are making requests to it. You can even set up alarms on API calls to your secrets, so you can try and see if someone is trying to gain unauthorized access to your secrets. There's a whole bunch of stuff that you can do with CloudWatch and CloudTrail to monitor access to your secrets. And finally, Secrets Manager allows you to control the life cycle of secrets using a concept called rotation. And this is just the idea that there's a couple of select AWS services that support this feature natively. And how it works is that Secrets Manager will automatically, on a scheduled interval, change the values of your secrets. So things like database, passwords, and stuff like that, it'll automatically rotate them out so that they'll change every, I don't know, it could be 6 months, could be 1 month. But this is just a good way to protect access to your database in case those credentials somehow get leaked. So I kind of want to double click on that key rotation concept because they do kind of stress it out in the AWS console. So let's talk about how it works. So the services that are natively supported with key rotation are Amazon Redshift, Amazon DocumentDB, aka MongoDB for AWS, and then Amazon Relational Database Service, or Amazon RDS. And so how key rotation works is that it starts with you as the user, like you either as an individual or you build an application that's going to be interacting with these AWS services. Now we learned that behind the scenes, you, like a good individual, you're going to store your credentials that are used to access these databases in Secrets Manager. And so, you're going to be interacting with Secrets Manager first, get the credentials, and then call the database, whatever. And so if you want to use key rotation with these three specific services, there is a configuration step where there's kind of a back channel that happens between these services and between Secret Manager. And on a scheduled rotation, these services will rotate out their credentials, their database credentials that you as the user over here are interacting with your database with. So what'll happen is that, say you're storing like admin123 and password123 over here for your DocumentDB database. Say you set up a key rotation time frame to be on a kind of a schedule. People usually do this, by the way, like late at night when no one's using their application. What Secrets Manager and this service will do is that Secrets Manager does this clever thing where it clones the user and then swaps out the credentials. And this is completely transparent to you. So all you see as the user is that now you're calling Secrets Manager again, get secret value API, and you're just getting a different set of credentials back and calling the database over here, and everything just continues to work without you even realizing that a rotation occurred. So that's how this works. Now, AWS does realize that, not everyone uses these services, or maybe they want rotation on some other thing that they're storing with another AWS service. So there is a manual way to do this if that's your use case. And the way this works is, say for instance that we have an application out over here that wants to use Secrets Manager and they want to do rotation for their credentials. So what you would do is you would create your secret, and you can specify a rotation policy using a Lambda function. And similarly to what we did with that scheduled rotation, you can also set up a scheduled rotation to invoke that Lambda function. And the idea is, for that particular secret, you invoke the function is going to compute something and return back to Secrets Manager the value that you are now going to store as the secret. So that's how this works. But for a lot of applications, a lot of use cases, you don't really need to do key rotation in general. Like think about the Twitter API use case. You don't really rotate your Twitter API. You don't really rotate any other developer APIs, at least that I'm aware of, very often. And when you do, it's manual. So rotation is kind of like a unique use case that may not be relevant for you, but it's important to know that it exists. All right, so that is it for rotation. Now, before we get into the console, I just want to talk about pricing really quick because it is important to know about. So for Secrets Manager, it is a candidate for a 30-day free trial period. So within 30 days of creating your first secret, everything is totally free. You can create as many secrets as you want. You can use the API as much as you want. But after that, it's 40 cents per secret per month. Now, some of you may be saying that's pretty expensive. Kind of agree with you. It's pretty pricey, but you do get guaranteed availability, pretty much guaranteed. I say guaranteed in quotes, things go down, but very high levels of availability, very high levels of scale. You get encryption on your data. There's a whole bunch of benefits to using this type of service, and of course, centralized access. And then in addition to just the flat cost per month, there is a charge for 5 cents per 10,000 get secret value API calls. So this really isn't a lot of money. So it's not going to break the bank for anyone. And in addition, secrets are usually highly cacheable values. So something like a Twitter API key, you can cache that value in memory in your application code. So you don't need to call get secret value a million times in response to whatever your application is doing. All right, so that's the idea with Secrets Manager. Let's head over into the AWS console now. I'll show you how to create a secret and how to access it from a Lambda function. All right, guys, so here we are in the AWS console. Let's head over to the Secrets Manager section and create our secret key. Okay, so typed in secret there. We're going to go to Secrets Manager. And you can see here, I already have a secret from a project I was working on previously, but what we want to do here is go to the top right here and click on Store a New Secret. And so this is now asking us what type of secret are we going to use here? Is it going to be credentials for an Amazon RDS database? Is it going to be for a DocumentDB database? Is it going to be for a Redshift cluster? Is it going to be for another type of database? Or is it just going to be something else that's not database related? Like could be plain text. In the case that we were talking about the Twitter API key, this is what you would do here. Now, it's important to note that if you choose any of these like database values, you do need to actually have a database, because part of the configuration is like selecting the database that you want to configure against. So I don't have any configured on this account, at least right now. And so this isn't going to work for me. But what we are going to use in this case for continuing down the path of the Twitter API example is this other type of secret here. So I'm going to click on that. And you can see it's asking us now for key value pairs. And so what we want to do here, and by the way, there's also plain text supported. So if you just wanted to like dump the API key in here just as plain text, you can. But what I'm going to do is I'm going to use a dictionary. So just to follow the example here. So I think we said like Twitter API key here. And I can't remember what value we said, but I'm just going to say value 1, 2, 3, 4, 5. Just bear with me here. You can also add multiple rows here. So this can be a full-fledged dictionary object. Not sure what the size is. You probably have to check the documentation, but I'm sure it can support like many hundreds of rows here if you need. The second thing that you need to answer is in regards to the encryption key. So there is a caveat here that I wanted to call out really quick. This is the KMS key that is going to encrypt your data while it is in transit and while it is at rest. Now, by default, when you create an AWS account, AWS creates a managed KMS key for you. So this is what the pre-filled option is here. So AWS/Secrets Manager, this is the managed secret that AWS will use. Now, you can also use your own KMS key in case you want to have more control over your KMS key, maybe the rotation schedule, maybe things like who has access to it. Now, the thing to keep in mind is that when you're accessing the resource that is stored here, so Twitter API key in our case, if you're using just the normal AWS managed secret key, then you just need access, IAM access to that get secret value API. If you are using your own, in my case, I have one called test key here. Not sure what this area, oh, I'm going to delete this, so this isn't going to work actually. But if you're using your own key, then you also need to have the IAM permission, which is KMS decrypt. And that's because in order to access the value, it needs to use your KMS key to decrypt. So that's just a caveat that you need to understand here. And it could be a little bit of a headache for you later on, so I just wanted to call it out. Okay, so that's it for the encryption key. Let's go ahead and click on next now. You can name this whatever you want. Let's just call this my-key. And tags, we don't need that. Okay, so this is where you would schedule rotation if you wanted it. So if you enabled automatic rotation here, there's two things that you need to do. The first thing is you need to create the rotation schedule. You can either do this using just the pre-populated options here, or you can write a cron expression or this kind of pseudo cron expression that AWS uses to create the interval that you want to rotate on. And also you need to specify the Lambda function that's going to be responsible for rotating the credentials out. Now, if you're using Redshift, RDS, or I think I said DocumentDB, you don't need to do this. This is all managed for you automatically. But in the case like me, where I'm not using any of those options, the only choice is to use Lambda. So I'm not going to do that in this demonstration because it doesn't make sense to rotate a Twitter key, but that's how you could do it theoretically. All right, so we should be good here. Let's click on next and scroll all the way down. This is just a confirmation page. This is kind of handy too. This shows you how to access it in a variety of different languages here. And we're going to be doing my demonstration in Python. So I'm going to have something pretty similar to this that you will see in a moment. So go ahead and click on store now. And if you click on refresh, yeah, we should see it. So my key is called my-key, very creative of me. And if we want to see what is inside of this key, since I am an administrative user and I have access to everything in this AWS account, I can. But ideally what you would want to do is you would kind of want to lock down this secret here. And so if you want to actually see what's in there, you can just say retrieve secret value, and then there you go. So there's my Twitter API key, and there is my secret value. You can also set up a resource policy. So this is very, very handy to use to lock down access to it. So resource policies and IAM kind of go hand in hand. IAM basically tells AWS which users have access to what, and resource policies tell AWS who or what has access to this particular resource. So if you specify a resource policy, you also need to have a compliant IAM policy, and both of them line up. So for example, in the resource policy, you can say only users that are part of this group. And in the IAM side of this equation, you may say the user is part of this group. So that's how these two things can be used to lock down access to this secret. And if you click on like info here, it gives you some information here. I think I have a video on resource policies with S3. If you want to watch that one, just type in like S3 resource policies on my channel and I talk about this stuff in detail. It's literally the exact same concept. Resource policy is something that is, a large concept applied to many different AWS services. Anyways, all we really need to remember now is that we called our key my-key and we called this the Twitter API key. So I'm just going to copy that because I forget things a lot. We're going to go to Lambda now, and I'm going to show you how to access this thing from a Lambda function. And I also have another video on this, so I will show you how I set this entire thing up using Lambda functions, including all the permissions that I needed. So I believe my thing is called Secrets Manager Key Retriever. So let's click on this and take a look at our code really quick. All right, so we're importing some things. Secret name, this needs to change to my-key. And what do we need? What are we doing here? So we're setting up our clients. This is going to be a client of type Secrets Manager, and we just need to pass in your region name, which is US East 1 in my case. And then in our Lambda handler, we're making that call. We're storing in a variable, a response object, and we're using the Secrets Manager client to call the get secret value. We're passing in the my-key, which is our secret name. We're printing out the response. This is just the raw response. And then we're extracting out of the response it's a dictionary. So we're extracting out the secret string, which is going to contain the Twitter API key and that whatever password I put in, 1, 2, 3, 4, 5. Now I'm going to just press deploy really quick. We're going to test this out in a second, but before we do, wanted to just show you the configuration for the permissions. So I have a role here that I had to specially craft, and can I do that? Well, yeah, okay, that opens up. Perfect. And if you take a look at this role, this one has KMS decrypt policy attached to it. It also has a secrets policy to allow me to call get secret value. And so I'll make this available in addition to the Lambda code so that you can copy this stuff out and don't have to, write it down from the video. Anyways, let's go back if I can. All right, there we go. And let's click on test now. And we should be able, hopefully if this worked, get access to, there it is, our Twitter API key, which is currently being stored in Secrets Manager. So I hope you enjoyed this video. If you want to see how I built this Lambda function integrating with Secrets Manager, I'll put the video link on the right here. And thanks so much for watching. Don't forget to like and subscribe. I'll see you next time.